Howdy everybody, Steve here, KM9G. Today I've got a little bit of a rant to share with you. Remember when we were young, when we were kids, and there was like 4 total brands, and you had your favorite, and you would die on that battlefield to protect your honor for you and your brand? We don't have that anymore. We have like 10,000 brands, and out of the 10,000 brands, like 9,000 of them are the exact same product with a different label and maybe a different color box. And so we compound that one more time to make it even worse, because now the specifications for devices change. So first we had USB, then we had USB-QC, now we have USB-C, and then we have USB-C PD, which I think C and PD came out at the exact same time, but we also have PPS on top of that. And I just threw out a bunch of acronym soup that a lot of you were going, what the heck is he talking about? So what I have is I have 3 different power strips, because my original power strip that I got from Anker blew up. My original power strip I got from Anker also had a problem with it. Problem for us ham radio types. USB-C puts out 12 volts. And depending on which device you get, usually it's like 2.5 to 3 amps, which is perfect. Where is it? Perfect for a QRP radio. It's right here. I carry this thing with me a lot. This is a little tiny battery pack from a brand I've never heard of before. VRURC. I have no clue. Like, we have brands that we can't even pronounce the name of. That battery pack will power my ICOM 705 or my Zygu 6100 or any of these other 5-watt, 10-watt QRP radios for quite a while. It'll even power like a Raspberry Pi or something along those lines. But the Anker stuff doesn't put out the 12 volts, so it can't get it done. On top of that, these stupid Raspberry Pi things here, they want a very specific voltage or they start whining incessantly. They want 5.1 volts from the power supply and not just 5. So even though it has the USB port on the side of it and that's how you give it power, it won't accept the power. So I've got a couple of different testing criteria. I've got 3 different types of USB surge strips, and half of my shack has been disabled because for some reason the RV manufacturer put one over there underneath the shelf, one AC, 120 volt AC port in this room. This used to be a bunkhouse, and it would sleep 4 people if you packed it to the gills. 4 people, 1 AC outlet. Technically there's another one here, but that was behind the TV. So you have like 3 total plugs in a room for 4 human beings to share space in, especially 4 modern human beings with switches and tablets and cell phones and headphones that need recharging and all kinds of crud like that. And 1 TV for 4 people in the same, that ain't happening. There actually never was a TV here. So I put up my wall of awesome, which is my inverter and my solar charge controller and my battery testing station and all kinds of stuff. And that outlet is behind it. So what I'm going to do is whichever one of these passes, I've got 2, and one's going on one side of the cabinet, the other's going on the other side of the cabinet. So I've got more AC ports, and I only really wanted like 4 AC outlets, and it's pretty cool that they make these devices. Let's stop rambling and let's get over to the devices already. These are the 3 in question, and they all have wildly different specs, and they're almost impossible to read. So as an example, let's start with the smallest one on top, and they're all about the same size once you get the box open. This one says 30 watts, 2 USB-A, 2 USB-C, and it actually looks pretty sexy when you get it out of the glare. But I don't think that 30 watts is true. So let's take a look here. Rated power 1,250 watts max. So that's on the AC, the 120 volt AC outlets. And these are 15 amps, so 12 volts times 15 gets you somewhere in that, slightly derated. So it's not even a full 15 amps. Nice. Yeah, a full 15 amps, which is what these shapes are here. A 20 amp circuit looks a little bit different. I'll put a picture on the screen here for you. It's got a dog leg off to the side. But a full 120 volts at 15 amps, which is what you would plug this thing into, would be 1,800 watts. And I really don't want to plug this 4 outlet breakout through one cable into one 15 amp circuit and run a full 15 amps through all of that. Like, most of the human nature stuff that we were going to do with this isn't going to equal out to 1,800 watts. But again, it's got to be a thing. 30 watts. So the 30 watt part is what's interesting to me. So there we go. USB C1 plus C2 output, 5 volts, 3 amps, 15 watts max. And the USB C1 and C2 output will do 5 volts, 3 amps, 9 volts, 3 amps, 12 volts, 2.5 amps, 15 volts, 2 amps, 20 volts, 1.5 amps, 30 watts max per port. So even though this thing looks really sexy, it probably won't charge your laptops. And that's one of the things that I need, is the ability to charge a laptop. This one here is made by Hanikani. Sure, because like Versa I can pronounce, but Hanikani I have no idea. And there are no specs on the outside of this one. So let's take a look and see if there's any specs on the inside of this one. There's a little tab. They get me every time. Oh, and one of the other things, no specs at all. One of the other things that I needed was a right angle plug to go behind that board on my wall of awesome. This one has a ton of ports on it. 2 on each side, and then USB on the bottom, and then 4 on the top. So that's 6 AC outlets, which I don't really need 6. I need a printer, I need a monitor, and then I need like 1 extra. Okay, this is white on white. It's embossed, so it's even hard for me to read. USB-C 1 output, 5 volts 3 amps, 9 volts 3 amps, 12 volts 2.5 amps, 15 volts 2 amps, 20 volts 1.5 amps. So the same thing, 30 watt PD, so still probably not enough. And it says 1875 watts max, but again, I wouldn't expect to, melt plastic with something like this. This is kind of the same kind of plastic that you could do on your own 3D printer. It's a little textured. Is there a manual in the box? No, you get nothing and you'll like it. Hanikani. Okay, sure. Since we got the Hanikani out, we might as well get the Versa out, which is made by Tessan, the Tessan Versa, and see how this looks. Oh, we do have a little bit of a owner's manual in here. Yep, doesn't really say much more than I already told you. There's the specs if you want to pause, and these are the same specs that are on the other one except for the 1250 watt versus 18 something watt output. This is smoother plastic. It's got a nice little design. I don't know if you guys can pick. Yeah, you can see that on camera. That looks pretty cool. There's a reset button there for your surge protector. All the stuff is written on the bottom, which is important that it's here because I'm gonna throw this away. It's important that all that stuff's there. I already read you those specs, but already, if I had to choose between 2 30-watt devices, this one would win just because it's sexier than this one. It just looks like they have some more attention to detail. So this one's not bad, but it's 30 watts, and 30 watts USB-C probably won't charge my laptop. And I had to hunt for this one in order to get it. Two tests that are on the table that need to be done is can it charge my laptop and will it run my Raspberry Pi without complaining? And then this one here, big box. And it's got the GAN, which is the type of circuitry, the stuff that the circuitry is made out of. So the packaging is slightly worse, but technically slightly better for shipping. It was designed, oh, there's a user's guide. It was designed to be destroyed in shipping. And this one doesn't look bad either. This one looks like it's a product that somebody put some thought into. And we have way more ports. So this one's already leading the pack. It says laptop and smartphone, and then it says tablet, and then it says nothing and nothing. So C1, C2, C3, C4, most likely. All right, so this one here is written on the back, and that's kind of what I thought. They indicate it. So the different ports do different things. They provide different amounts of output. So we have C1, C2, C3, and C4. C1 is 5 volts 3 amps, 9 volts 3 amps, 12 volts 2.5 amps, 20 volts 3.25 amps. And the C2 is not as much. 5 volts, 9 volts, 12 volts, and no 20 volts at all. 5 volts 3 amps, 9 volts 2.2 amps versus 3 amps. 12 volts, 1.67 amps versus 2.5 amps, and no 20 amps versus 20 amps. No 20 volts versus 20 volts. Did I say amps that whole time? You all know what I meant. 20 volts, 3.25 amps is actually, I don't know how they do 12 volts, 2.5 and 20 volts, 3.25, but 20 volts, 3.25 is actually really nice. I might be able to take a buck converter and convert the 20 volts, 3.25 amps down to 12 volts, more than 2.5 amps. Ohm's law stuff. Stuff you got on your technician test way back when. Type C, port 3 and port 4. 5 volts, 3 amps, 5 volts, 4 amps. That's all you get out of those. So that'll be good for, Raspberry Pis and cell phones and stuff, I hope. And then the USB-A ports 2, 3, and 4. Where's USB-A 1? Oh, there it is, down there. Oh, wow, USB-A1 is good too. Hang on, USB-A1 doesn't make sense. USB-A2, 3, and 4 are 5 volts, 3 amps total, period. USB-A1, does it have an indicator on it? USB-A1 is the QC port, and the rest of them are not QC. That's what it is. All right, so the QC spec that I talked about in the opening rant. 5 volts 3 amps, 9 volts 2 amps, 12 volts 1.5 amps, 5 volts at 4 amps, or 20 volts at 1.5 amps. So this one here already looks like it's the winner across the board. And if we do some math, 12 volts times 2.5 amps is 30 watts still. So all of these, even though this thing says 200 watts, yeah, okay, so that's closer. That's some compound math there. I'm gonna have to do that on paper and get back to you. All right, so C1 is
20 volts times 3.25 amps. C2, I'm taking the maximum rating out of each of these. 12 volts times 1.67. C3 is 5 volts 4 amps, which is also C4, which is going to be another 5 volts times 4 amps. And then A1 is 20 volts 1.5, and then A2, A3, A4 are all the same, 5 volts 3 amps. All right, so this is 15, 15, 15, 20, 20. And let's do this real quick. I went to public school, so don't laugh at me. 20 times 3.25 is 65. That's going to do good for the laptop. 12 times 1.67, that's the weird one, is 20.04. We'll probably just skip that. And then 20 times 1.5 is 30.
So now let's add all of those up, and it's 65 plus 20 plus 20 plus 20 plus 30 plus 15 plus 15 plus 15 is 200 watts. So this one is the winner. But man, you have to do math and you have to trust and all this kind of stuff. There's nothing wrong with this one here. But what they're saying here is that these are 30 watts total. Even though you could do what we did here and add all these up individually, like we did on this one here specifically says USB output total 30 watts. So do not exceed 30 watts. So it looks good, it's compact, but 30 watts only isn't going to get my laptop charged. This thing here is specifically my Apple logo, so you know it's legit. And it is the USB-C power adapter for my MacBook Pro, which is a 2024 model. And it says 70 watts output, which means that this is going to provide a decent amount of power to keep the laptop happy and feed it, but it'll also be fine at 65 watts. If you get down to 30 watts, it'll probably charge if the laptop is off, but not if you're trying to, like, you know, surf the web and render video and stuff. But this one here looks like it's the overall winner. Number of ports, stylized, everything. And where do we go from here? So I think what we need to do next is get these things plugged in and get some testing done and see what happens. That ought to be fun. This thing here is my T-Mobile home internet. It's currently plugged into its own adapter on AC power, but it is real finicky. It doesn't draw a lot of power. I think it's like 4 watts. It's like nothing. It's fantastic, especially for like off-grid stuff, but it's real finicky about what it likes to be plugged into. So we're gonna plug that in to the 200 watter, and we're gonna plug the laptop into the 200 watter. We're gonna plug the TV, a computer, and the Raspberry Pi in and verify that all the things do all the things. So I have this cable here plugged into the back of the T-Mobile router, and we're going to plug this into the smallest port I can find, because I really don't want to give up my PD port. And let's see if she lights up. I see nothing. I know nothing. Okay, so that's the PD port. The two regular USB-C ports. These ones here are supposed to be the boring ones. This one's supposed to be slightly spicy, and this one's supposed to be extra spicy. So I already know not to do those two. Let's try the slightly spicy one. I told you she was finicky. It's not there, whatever it is. Is there a light on this thing? There is no light on that thing. Let's plug it into the extra spicy one. I don't want to lose my extra spicy port, but I need my internet. And we boot it up. There's a little T logo there. I don't know, because it's a mirrored display. I don't know if you'll be able to see that or not. But it needs the extra spicy port. Man. Okay, so my battle plan calls for 2 of these. So I'm still okay. I can charge my laptop and I can provide extra high quality, extra low wattage power. I'm giving it another shot just because I want to. I want it to work so bad. Okay. So let's do the Tessan next. And I'm going to cheat. I'm going to plug this in here. I like the flat plugs. Let's plug it into the spiciest port we got on the Tessan Versa. It sounds like the Nissan Versa. Yeah. This one does not power that at all. I kind of didn't think it would after the test results. Do not daisy chain surge protectors like I'm doing here. I have a surge protector plugged into green light. Surge protector plugged into a surge protector plugged into a surge protector. This one here, C1. Which one is the spiciest port? C1 is 30 watts, all the flavors. No. Dang it. Okay, so that one is dead. Let's get the internet working again. I hate to give up I can't give up my spicy port. I need to test the laptop charging. You are no longer center stage. You are. Okay, so I'm going to do this on USB-C to USB-C, which is most likely what I'm going to encounter on the road. Let's do weakest port. We are charging. And then we can do strongest port, and we are charging. Okay, so this one's good. No display, no go to sleep, no sleep. All right, so weakest port on the Tessan Versa, charging. Strongest port on the Tessan Versa, charging, which means that this one's probably going to work. So we'll do weakest port on the Hanny-Coney, which is charging, and the strongest port on the Hanny-Coney, which is charging. And I can see because the battery changes to a charging symbol up there. I'm pretty sure you guys couldn't see that. Laptop out of the way. That is 2 tests passed. Next up, I need to plug in the television. And this is AC stuff. I would expect 100% of these to work, because why wouldn't you work with AC? Pull down my HDMI cable, pull up my computer, and right now, these are both plugged into the Hanny-Coney. And I need HDMI video. All right, so there's my HDMI video, and let's turn that on. So the computer has its white light on right there saying that it's working. The TV shows that it is doing the TV things. And the green lights coming out of the back of the TV are actually plugged into the USB-C port, USB-A port on the back of the television. So come on, you can do it. Come on, Grandpa Windows. There we go. Okay, so here's the real test. I have a Pi 4, which I'm going to plug into the TV that you guys saw, and we'll see if it throws up a voltage warning. And then I also have a Pi 5, and we'll see if it throws a voltage warning when it boots up. I don't remember what's on either of these 2 machines, so we'll get to see what that is together as well. All right, so we're going to start off with the Pi 4 and HDMI 1 for that. And then I need USB-C for power. And we will try this on the C2 port on the Hanny-Coney. All right, she booting. See my reflection. Hi, everybody. Trying her best. She's booting over here in the corner. Raspberry Pi desktop. This is the 32-bit version. So it's going to take an extra special long time, because Pi 4s are 64-bit. No complaints yet. Interesting. So I'm going to take the Pi 5 on top and plug it in. And we'll see. Red light on. Good. Red light back off again, because it went green because it's turning on. All right, and that one boots up a lot faster. And this power supply is not capable of supplying 5 volts at 5 amps. Power peripherals will be restricted, and that is true. So it's 5.1 volts, don't lie to me, and then 5 amps. So that one we already got a complaint on. All right, the Pi 5 has been shut down. You can see the red light. So I'm going to switch this to be powered off of the Tessan Versa. And we got the red light, which switched to the green light on the Pi. And how does my display up here look? Looks like I'm missing my menu bar. There it is. And we have the same error. Can't just do 5 volts, 5 amps in the upper corner over there. All right, so the Tessan Versa can't do it either. I'm going to switch the Pi 5 for the Pi 4. And we're still on the Tessan Versa. And that is booting up. And I see no error message on the screen for the Pi 4. So the Pi 4 is happy. And to be fair, the Pi 5 is also happy. It just doesn't have enough amperage coming in to provide power out to the peripherals. So the Pi 5 itself will run fine off of either the Hanny-Coney or the Tessan. All right, technically we have 2 more tests to do. And that is each one of these off of and that is the Pi 4 and the Pi 5 off of the, what is even the name of that thing? It just says adapter. Adapter. That's all you get. They're so proud of themselves, they don't even put a brand name on there. So the unbranded one is the one. Dongguan Yanhaozun Technology Company. Off of that one, the 200 watter. I'm going to put it in the lowest port and see what happens, because that's actually where I want it, is in the lowest port. And we got the rainbow display of awesomeness. And we'll come back when this thing is fully booted because it's going to take a while. All right, no complaints. I might actually just want to add a test to this on the Pi 5 because I think the Pi 5 is going to be happy on the lowest port. Well, I hope the Pi 5 is going to be happy on the lowest port, but I'd love for it to be happy on the lowest port and then also happy on the highest port. So we're plugged in, we're green lit, and we're booting. I see it in the corner. Are we going to get a message? We have no message. Oh no, there it is. I was just too impatient. Yep, same thing. No 5 volts and 5 amps for peripherals. But other than that, she's happy. Awesome. All right, so I shut the Pi down gracefully. We've got the red light. Let's try it on the QC port, the second from the best port, the penultimate port. And she's already booting up. Got our mouse cursor, got our menu bar. We have our complaint. Okay, so we can't do 5 volts, 5 amps out of that one either. All right, so we are turned off on there. Let's put it into the ultimate port, the best port. And still the same complaint. Can't get past it. All right, so that's actually kind of the results that I expected. The Raspberry Pi 5 is really finicky about the power that it receives. The Pi 4 is slightly less finicky, and then, on down the line as they get older and they were expected to be doing less things in the first place. The Honeycomb is $19. The Tessan is $23. And the big boy no-name brand is $37.87, $40, $20, $25, and $40. So I guess you kind of get what you pay for, but it's an unknown brand. It's an untrusted brand. How do I know this is good? I guess this is why we do reviews on YouTube. I can't really do a long-term review on this because I just got them and I needed to figure out which one to do. So if I do get some issues, I'll do a video on what I replace it with in the future when I come to replace it. Or I won't because I'll never have needed to replace it. The Anker one that I got before had lasted me a really long time. And the other day, I just smelled something funny and tracked it down, and it was the Anker unit. And I have no idea what caused the problem. They talk about needing a surge protector in RV parks, and I don't have one. I've never had one in the last 3 years. I've never had a problem until I got that surge, which blew up that power strip. And the power strip actually still worked after that. It just was no longer able to, provide surge protection because literally the components that did that went up in smoke. So it protected whatever it protected, but how it got the issue in the first place, I have no idea. So I guess, more work on battery power and less work on shore power is the answer to that. So I'll leave links in the description down below for all of these. They're all good for what they're rated at doing, but as ham radio operators and electronic consumer aficionados, we need better stuff than most people need. So get the no-name one. I hate to recommend a no-name solution, but this is why we test stuff. It doesn't really matter where it comes from. What matters is that it does the job that needs doing. And that 12-in-1 charging solution, 200-watt GAN4, wow, crazy amount of words, but out of all of those words, I couldn't make a brand name. That one is the one that won today's shootout. So if you want to see a guy test out weird electronics to do things that are kind of at their limits of what needs to be done, then this is the channel for you. Make sure you are subscribed by clicking the link down below the video and hitting the subscribe button. It is totally free. There's some other links down there for all of these products if you are interested in picking up any one of these. And if you have some success with a good brand that provides 5 volts, 5 amps for the Raspberry Pi and can charge a laptop and can run a QRP radio, then leave a comment down below, let me know, and I will play with one of them in the future as well. There's a video right over here I think you'll enjoy next. Thanks for being awesome. I'll see you over there.